We will conduct it in a doubt clearing manner. Okay, you if you have specific questions, you ask me, and we will try to clear the doubts. What happened in the last class was I was I was going through the assignments, and there I asked a very simple question. I wrote the code for an asynchronous D flip flop. I mean D flip flop with asynchronous reset, and I asked how will you turn this code of piece of code into something that describes D flip flop with synchronous reset. Very simple question. And one of the students said you need to add some extra circuitry. Then another student said no, just remove at the rest posage reset from the sensitivity list, and that will be it. So these are very simple concepts. Okay, uh, if you are not familiar with these concepts, especially sequential circuit, how to describe the sequential elements, etc., what is the difference between blocking and non-blocking assignments, if you do not understand, starting from this assignment onward, this assignment 5 and the assignments in the future, all of them will heavily use concepts of sequential circuit design. If you are not clear with the concepts now, it will be problematic because these are very basic concepts. Okay. So please clear your doubts as soon as possible. That's the reason we are having this. Otherwise, Friday class we could have uh, probably skip, because anyway your assignment has been given, all the problems has been described in detail. So if you have any doubt, you ask.
So I had a question.
Yes.
So this is regarding related to the Xilinx software. So in
Okay.
Xilinx, when I try to implement a D flip-flop with asynchronous reset and try to synthesize it, it gives me an error saying that the always block has multiple edges, and it also, like, if I try to separate that same always block into two and try to do it again, it says that Q is being driven by multiple
Yes,
drivers.
Q is being driven by multiple signals is a is an absolutely correct error. That should not be done. You cannot separate. I think I mentioned it in the last class yesterday. You can have multiple always blocks in your design, as many as you like, depending on the context. But one thing you have to ensure that the same signal cannot be the destination in these multiple always blocks, which means the same Q signal cannot be driven twice or thrice. It can be driven only once. Now, if you could email me the exact code, I can have a look, and the exact error message, I can have a look. This is a quite surprising error. I mean, I have not heard this error. Maybe the way you are describing is creating some problem. Otherwise, I'll need to myself go through the how the software behaves. Are you using Vivado or IAC?
ISC.
Okay.
So,
Uh,
yeah, what you said is correct, like the multiple drivers. But before that, I was
yeah.
like, this was my second attempt. Before that, when I was attempting to implement the D flip-flop with asynchronous reset, it was saying me that the always block cannot have multiple edges. Like it was having pause
Okay.
edge, clock, or neg edge reset, right? So it cannot have
No,
that.
you okay. So maybe this flip flop. Did you try posage reset also?
Uh, no,
Means
no, I haven't, but
yeah.
I,
So maybe
no, so
I'm
wait,
I'm
okay,
just
if I one second. So I remember my code correctly right now. So posage clock or posage reset. Basically, reset has to be one for reset to be applicable. So it was both posages. It was not negative.
okay. So why this is not working is a little surprising. Which means see, one possibility is the target. Uh, have you say what is your target FPG Arctic 7, or you have not yet gone to technology mapping? It is just you are just doing a behavioral simulation.
So the simulation is working, sir. The simulation is absolutely fine. So when
Okay,
I
when you try to
synthesize it,
synthesize it, yeah, okay, okay. So it might be possible that the device that you are targeting, say Arctic 7, I don't know which device you have set. So you have to set the device. Do you set the
So,
device, particular FPGA?
it's the same as the one which was done in the Xilinx installation tutorial, which was conducted by you guys.
So it should be Arctic 7. Okay, no, you should know the name of the device. It is
Sorry, sir. Yeah.
check if it is Arctic 7. Maybe it is something else. I don't know. Now, it might be possible that this Arctic 7 device does not have any asynchronous D flip-flop. I mean, D flip-flop with asynchronous reset. So it is asking the designer that remove the @ clock from the sensitivity list so that it can support a synchronous D flip-flop. So essentially, you are kind of getting bound to use synchronous D flip-flops with synchronous reset only. Okay, might be possible, but it's a slightly surprising. As I said in the tutorial last class, with synchronous reset, it is slightly easier to design the flip-flop. With asynchronous reset, it is might be slightly more difficult. So this might be the issue. Any other student has faced this issue? That if you if you have an asynchronous reset mechanism, your synthesis tool is complaining that sensitivity list or something like the always block. Any other student has faced this issue? I have not heard about this earlier. Okay, I mean, neither from students nor from research students, and our research students use the ISC software and the Arctic 7 FPGA day in, day out. Okay, so it is slightly surprising, but because you are saying, please email me the piece of code and the exact error message, and I will go through it. And first, please check. Okay, please check what is your target device, whether it is Arctic 7 or not. Okay, we are doing all our assignments targeting the Arctic 7 FPGA because that is what we have in our lab. Okay, so we use the Nexus 4 board in our lab that has the Arctic 7 FPGA. If you had been in campus, you would be using those FPGAs to map your design on them, basically, to actually map the design on the FPGA. But unfortunately, because of these online classes, you are not getting access to the FPGA boards. But please send me your code. Okay, I will try to debug and try to find out what is.
Sure, sir. I will recheck and send you a detailed email.
It has been reported earlier in the Xilinx forums that whatever target device you are using, that if first check if it is Arctic 7. Okay, if you are getting it with sure that it is with Arctic 7, you check, do a Google search that Arctic 7 does not support asynchronous reset in D flip-flops. So usually on Xilinx has a very active user community forum. Okay, so somebody in Xilinx forums would usually raise this concern or ask a question, and usually expert Xilinx users, many times Xilinx employees themselves know the detailed design and the in and out of all the actual circuits. They give the answers, and the answers are very authoritative because they know what they're talking about. Now, if this issue has been raised earlier, you will find resolution. I mean, it has been answered. If the answer is that Xilinx, that FPGA does not support asynchronous reset, then it's done. I mean, you have to go for synchronous reset. No way you can do it. Otherwise, it's slightly surprising. Yeah. Any other question? So just let me know what you find. Okay, just email me. If there is something to announce to the entire class, I will announce it after trying to resolve your issue. And I think most of you, if not all, are registered in the theory course. I have sent out an email last night about the notice for the second exam. Did you receive the email?
Yes, sir. Yes,
Okay.
sir.
Yeah. Okay, so any other question? So this is a very important, Ritovan, what you asked is very surprising, and if this is this is actually true. What your observation is true. It's a concern. So then, in that case, you have to write your code to for synchronous reset. Any other question? So another question that I am just okay. Let me just try to describe it by writing some code. Okay, so another question that the students ask is in the both the set of slides that have been uploaded on Moodle, you will find that there are examples where this type of say it like the D flip flops are being described in this way. Uh, yeah, and then suppose there is a reset or not, whatever. Uh, say if reset q equal to 1 tick be 0, else q equal to b. So you might ask that, sir, in the last class you said use non-blocking assignment. Why are you using blocking assignment here? Is this wrong or is this okay? What should I do? In this context, it is this piece of code is correct because there is, if you look at the structure of the always block and the if else block, there are no multiple statements corresponding to the if clause and the else clause. So if there are multiple statements in order, suppose after this if we said there was something else, or after this else there was something else, of course in that case you would need to add a begin and end here also. Uh, then there is a dependency, the question of dependency comes in. Okay, and in that case whether you use blocking assignment or non-blocking assignment matters. In these cases there is there is only one statement in each of the inside the if clause or inside the else clause. So there's no problem, you can use both, but as I said, for the sake of consistency, when you are describing pure sequential logic and you understand that you are describing pure sequential logic, you should use non-blocking assignments. This block of code describes pure sequential logic. Okay, so try to use it. Another point of concern is what to do if extremely simple finite state machines are going to be described. For example, an binary counter. Okay. Now, in the last class, I showed you why a template of describing finite state machines, which was quite, what should I say? It was simple, but it has three separate parts. Now, in a binary counter type of state machine, there is no output logic as such. The state value itself, their output logic. Okay, and the behavior is extremely simple. There is no need to separate out the input logic, output logic, all these things. There is no input logic. Okay, there is no next state logic. The next state logic is kind of inbuilt inside the machine. Okay, it just increments. That is the next state logic. So in those type of simple counters, say you have a 6-bit counter, so you can have range 5 to 0 count. Okay, and that is, say, that is also your output. You can have an input reset and a clock. Then you can write always @ posage clock. So because if it is synchronous reset, if reset, the behavior, that is absolutely fine. I have a question related to this. So students, please try, any of you please try to answer. The question is, if in place of 6-tick B0, if I had written 0, first of all, is it correct? And secondly, if it is correct, what is the difference between what I wrote with the 0 version and what I wrote with the 6-tick B0? These two different things.
So actually, this would work in case of 0, I think, because in this case, all of the 6 lines would become 0. Even if we write just 0, or if we write 6 tick B 0. However, if it were 1 or something like that, then all of the 6 lines would not have been 1, and it would have not reset all of the 6.
No, that is well understood. That is understood that if you write 0 and if you want a non-zero reset state, then it cannot give you that value. That is trivial. So your answer is this is correct, right? I mean, this will also work.
Uh,
First part is this will work or not? This will work,
yes,
right?
sir. It seems like
It
it
will
will work.
work. Fine. Yeah, correct. This will work. Second part of the question is, what is the difference between this and what I wrote earlier? Like this, if I had written 6-tick B0. Internally, how does the Verilog compiler treat these two cases? What is the difference?
Sir, I guess the 0 will be treated as a 32-bit number.
Okay. And then what will happen?
Um, so it'll take more space, or like it'll take more time to process something.
No. Yeah, your answer is correct. Answer is correct, and very good answer. That if you do not uh, define the width of the signal, width of the constant, the bit width of the constant, and you it is treated, and you do not define the base like here. By default, the base is 10 for constant. So this is a decimal number 0, and by default, the type is an int. So integers in Verilog are 32 bits. Okay. So what will
Yes.
happen here is that you will have the right hand side to be a 32-bit quantity and the left hand side to be something which can hold maximum 6 bits. So what will happen is the compiler will take a 32-bit right hand side, truncate 26 bits and assign the LSB 6 bits to the left hand side. And this behavior is true even if you had written, say, for example, if by mistake or whatever, but if you had written something like this on the right hand side. Say if you had written tick B0, then also it's the same behavior. It sees on the right hand side something whose width does not match the left hand side, and it truncates from the MSB 6 bits and assigns the 6 bits. As far as I remember, IAC or other, I mean, definitely other compilers, I think IAC also, it gives a warning when this, what I wrote just now, this 12 tick B0, this case happens. It gives an explicit warning during compilation that there is a width mismatch between the stuff on the right hand side and on the left hand side of an assignment statement. So this was truncated. Right hand side was truncated. However, I am not sure it gives a warning if the right hand side is simply this. Okay. Because it's not an error, but an truncation will still be happening. I'm not sure it gives a warning, but it's okay. I mean, you can use it. I personally prefer to use, unless I'm forced, uh, or unless the situation is very, very simple, like this piece of code where I have written count plus one. I personally like to use binary base 2 constants, and I like to personally mention the explicit bit width, constant width. Like in this case, I would have written it like 6 tick B0. Now it is your choice. There are advanced versions of Verilog. What we are learning now is basically called Verilog 2001. There are newer versions of Verilog, like Verilog 2012, which is called System Verilog, which makes this bus width handling very, very simple, simple to handle exercise, because you can just write in these cases tick 0 without mentioning the base, without mentioning the width, any nothing. You can just write tick 0 and then the compiler, leave it on the compiler to automatically assign exactly the same width that you want, and there would be no truncation, etc. Okay. But that I don't think is supported by Verilog in the version of Verilog that you are using. So if you write something like tick 0, it will not compile. It will throw an compilation error saying that this syntax is wrong. So anyways, so that was also something that very simple, thing, but just that you, I mean, so that you understand. Okay, now let me also just ask you another question regarding this. And these examples are there in the, I think there some examples are very nicely described in the slide that DM taught from and which has been uploaded. So suppose you want this type of behavior, like there is a flip-flops in series. Okay, if you want this type of behavior, you should use non-blocking assignment, because the non-blocking assignment essentially models the memory property. Although at the clock edge, the first flip-flop Q1 value would start changing that would not affect the second flip-flop's value change at the output. It will still consider the first flip-flop's old value, which means the value change at the output of at the output of the second flip-flop, that is Q2, it will use the old value of the first flip-flop and update itself. So it does not wait when will the first flip-flop finish updating its value and then it will update its old value, which means in computer science terminology, it says that this value change in the second flip-flop does not block. It is not waiting for an event to happen. Okay. This concept of blocking you will also learn in great detail when you later study operating systems and how synchronization is performed, semaphores and all these things. Then when you study processes, a relationship between a parent process and a child process, etc. But anyways, my point here is that if you have a series of flip-flops, which is essentially you will need in your shift register designs, you should use non-blocking assignment. There are very nice detailed examples given in the slides that DM taught from, and also there are some examples of Johnson counters and shift registers in the slide that I was teaching from in the last days. I didn't cover those portions, but I remember they are there. So also have a look. Also on the internet you will find plenty of examples. Okay, so don't get confused. How is this happening that the output of the first flip-flop on the back is changing, but the old flip-flop is changing with its old value, with the old value? Of course, that happens all the time in flip-flops. That's how shift registers work. There is no race between these two signals, that who is going to change value first and then what is going to happen to Q2. And there is no race. Okay. So this is also something that you should remember. Another thing you should avoid is this incomplete case statement. Because in some of the problems, you might need to use a case statement inside always blocks to denote combinational logic. Let me show you an example from the slide. Yeah, I think there is one example of an incomplete case statement. And what happens if you use incomplete case? Yeah. So this is page number 51. So first of all, let us look at the correct design. Okay. So this is a combinational circuit. Okay, which has an input called car_state, and there is an output called flag. Okay, there is a and the flag has to be a reg type variable because it appears on the left hand side of assignment statements inside always blocks. Now the problem with this, not this one. This is the correct version. Here, because car_state is a 2-bit quantity, it can take 4 different values. The problem that can happen is that this case statement only describes 3 of them. Okay. What happens to the case when the car_state is 2 is not known, not defined? So for that, you can have a default clause in the case statement that every other case which has not been handled by these two, all other cases, this default means all other clauses. All other situations flag will be 0, and accordingly a combinational logic block will be inferred. Now, a common mistake that students make here is that to forget the default clause. To forget the default clause, what does the compiler understand from your code? That you have to think. The compiler sees that there is a case block in which 3 out of 4 cases are covered. What happens to the other case is not known. Because it is not known, the compiler treats this piece of code very defensively. First of all, compiler does not make any assumption about what the user intended or what the user actually wanted but made a mistake. Compiler does not interpret this human mind. Okay, it just looks at the code and implements what it sees. So how defensively it assumes that because the user has not mentioned anything about what to do when car underscore state is 2, what to do when this is 2 is not known, I will preserve whatever value was there earlier if case 2 happens, because I don't know what to do. If the compiler says the user has not told me what to do if car underscore state is 2. So I will just preserve whatever value was there earlier at the output variable flag. But this thing means that I will remember the old value that was there in flag. This is the classic definition of the behavior of a latch, right? So there is a memory element in it. What it does is it implements this piece of code as a combination of one latch. The latch only operates when the car underscore state is at value 2, and it works by preserving the old value. Otherwise, when it sees 0 or 1 or 3, it goes to the values that are mentioned. Also, as I said, that everything here has been defined in decimal notation. It is, I mean, I would have probably written it like 2 tick b0, comma 2 tick b01 flag equal to 2 tick b10, etc. But again, this is absolutely, I mean, in the, you can write it using decimal, but then this truncation business will be going. Truncation sometimes creates problems when you try to implement the circuit. That's the reason I'm saying that it is better explicitly mention the width and use a base 2. I mean, binary notation or maybe hex notation also you can use if it's a very wide signal. But truncation sometimes creates problems during compilation. Okay, so this is the problem of latch inference. Logic inference is basically the mechanism of the compiler tool inferring what the hardware should be from the way the code has been written. And this Verilog HDL follows exactly the same principle as any other programming language. Garbage in, garbage out. Okay. It is not a magical compiler with godlike abilities to understand human mind or the designer's mind. You write wrong code, you will get wrong circuit implementation. Okay. So as a designer, it is your task to know about and recognize the common mistakes and learn how to avoid them, so that the circuit that you finally end up with works exactly as you want. Okay. Anything else, students, that you want me to discuss about sequential logic, or anything else about the syntax or any fine points of the language?
Sir,
Yes.
so in the first three questions, let's talk about this. So in the second question, for the test bench, so do we need to implement a shift register itself, or can we use the for construct in Verilog
Yeah,
for
you can
supplying?
use the for also.
Okay, thank you.
You don't need to implement share. The second question does not ask you to implement a shift register, right?
No, so for the test bench, I meant
For
like
the
we have to
test bench,
keep
I think
supplying.
you can use the for. That will be much easier, I guess.
Okay.
But anyways, if you want to use shift register, that also is fine, because the shift register will be required in your question 4. It is up to you. I think one student also asked this in the last class. Yeah. Anything else? Okay, so if you do not have too many questions, then we can break for today's class. And you keep on solving the assignment. And if you face those type of strange issues like asynchronous flip-flop is not getting supported, then you go for a synchronous design. What to do? Okay. I mean, synchronous reset the flip-flop, not much we can do, but I'm also slightly surprised hearing this. Okay, students, anything else? Otherwise, I'll break. Okay, thank you then.
Bye.
Bye.
Thank you, sir.
Thank you, sir.